Yeah. So you missed last week's class? You did not miss much. You just missed the word phototropism that will relate to today. Okay, ready. Adam said he'll be in a car, but I don't know where's Adam. Okay, now, just to go through a little bit what we learned last week. Last week, this whole chapter is all about the plant's response. How the plant responds to the surrounding. Why do they need to respond? Why do you need to respond to surrounding? Why do you need to respond to food? Why do you need to respond to temperature? Right? At the end of the day, it's for you to grow, for you to survive. Plants also have the same thing, right? So they don't just stand there and just be that one shape. They have to respond in order to survive. If not, they're gonna die. Right? So last week we learned the ways they respond is by tropism method. That means they will bend wherever the stimulus, remember stimulus? Light, gravity, wherever they come from, I will bend towards them. It's the form of growth and survival, correct? Now, last week we also learned about this thing that I'm just gonna focus on phototropism that you learned in Form 3 and Standard 6, yeah. Okay. So now we're going to go into why do they bend? What is the thing that causes them to bend? It is this hormone called auxin. So all this bending is because of auxin, because of plant hormones. Okay, we're going to focus them. Okay, it's because of plant hormones that we have over here. One of them is auxin hormone. So today we will go into, okay, all the hormones in the plants. Can you list down all the hormones in humans? I want you to type for everyone to see. List down as many hormones as you can remember. Go. ADH, good. FSH, GH, good. LH, progesterone, good. Estrogen, good. Wow, wrong. Some more? I forgot, lol. Sugar, hello. Glucose, testosterone, good. Aldosterone, good. Sugar, I and G. Who controls your sugar level? Insulin, yes, Yashini. Okay, insulin, glucagon, GnRH, all of this are human hormones. You see, so many. Plants only got 5 only, you see? So you just have to know plant hormones today. So we're going to start off and see the names of the hormones. Pronounce the first name, everybody. Auxin, good. Next. Gibberellin. Next. Cytokinin. Next, abscisic acid. Okay, pronounce properly, yeah. And lastly, ethylene. Okay, okay. Now, let's start one by one. What is the meaning of phytohormone? Last week we learned, or last time I taught you the prefix, the word phyto means plants, correct or not? So basically plant hormones. Yeah. So what is the meaning of a plant hormone? So plant hormone for what? You need for growth, to control every process. So it's a chemical substance that stimulates responses in plants. Teacher, I skipped the word coordinate. Can it's fine. But you must have the word stimulate response in plants. Remember, students, at low concentration. Just like human hormones, you just need little bit. You give too much, it will go the negative way. Yeah? Right? So remember everything in small amount. Hormones especially, low concentration. Make sure this keyword here you know. Understand? So we're going to start off with the first hormone called auxin. Student, what do you see here? What is this animal? Ox, very good. Okay, it is a long ox, correct? Not so. It is a long ox. So oxen. Just remember. Just have in your picture of a mind of a long ox. The purpose is for cell elongation. Okay, it makes the cell longer, lengthens the cell. So long ox. Okay, so oxin for elongation. Now, look here, a cell which is like that will become longer. Now, which chapter did you learn about that the cells become longer in Form 5, in plant cells? Which zone is that called? What is C2? Chapter 2? No. Chapter 1. Zone of cell division, zone of cell elongation, zone of cell differentiation. Do you remember this zone? 3 zones in your plant? Yes, no? Right? Now, this second zone here is the zone of cell elongation. Now, where does all this process take place? In the tip of the what? And tip of the what? Tip of the shoots and tip of the roots. That's the keyword, correct or not? So if I were to tell you, if I give a plant auxin or the plant produce auxin, do you think the plant will grow taller or shorter? It won't grow shorter, right? Obviously, the answer is grow taller, correct or not? So let's look over here. This is the most important point of all. I will go through one by one, but later I'll tell you, because some smart students, they want to know everything, right? Because textbook, everything is just words, and then all of you like, oh, okay. So I'm going to frame your mind, make it easier. All right? Now, let's look here. Auxin, the first 3 hormones, one of them is auxin, right? It's a very positive hormone. It's like very encouraging one. Grow, 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 grow taller, grow longer, doesn't matter, just grow. Okay, you see the first one, stimulates cell elongation. So it makes the plant longer, correct? Next thing, look, notice over here, stimulates cell division in cambium. That means basically stimulates secondary growth. You know what secondary growth? Growth in diameter, correct? It stimulates, hey, grow, grow, grow. Okay, this is a very positive hormone. Next, very important here, it is very important in phototropism and geotropism. Now, we're going to relate this thing to page, let me check it. What page is this? Page 13, page 14 and 15. Okay, so what I'm going to put over here. Okay, so this one is notes, page 14, and this is notes, page 15. This is for your intercrossing chapter study. So that when you study this one, you read back this one, oh, it's actually talking about this thing. So it's the same thing I restudy again. So you don't have to stress, right? Show you relationship here. This is important. Okay, we're going to see in 14, 15, how is auxin going to help in phototropism and geotropism? Understand? Okay, next up. It stimulates the development of apical dominance. Whoa. Apical dominance. The word dominance means dominate. Stronger or weaker? Stronger, right? Yeah. Apical means what? What is the meaning of apical? Apex. Okay, do you know where's the plant apex? Apex means at the tip of the plant. So if these are the leaves and all, this area is called the apex, right? So basically, I'm making the plant grow dominantly on the apex. Means I am making the plant to grow upwards. That means the apex part dominating the growth. Understand? So this is called apical dominance. Understand not? The tip of the plant and the tip of the root grow. Very positive, you see, very encouraging kind of hormones. Can? Next up, stimulates the growth of, pronounce this word, adventitious roots. What are adventitious roots? Now, let me ask you, usually where are the roots located? Underground, right? Correct? The roots are located underground. Yeah? Now, adventitious roots means I make the root grow out, or the plant make the root grow out from non-root parts. That means other than roots, such as the stem. Suddenly got roots coming out from here. These are called adventitious roots. Wow, what a interesting name. Okay, basically roots that grow out from plant other than the roots. You lack. Okay. Okay. Testing. Are you okay over there? Over there now? See how? Can there? Can? I think, yeah, thunderstorm coming already. Okay, again, adventitious roots are roots that comes out from the plant other than the roots. That means the stem. Okay, next up. Inhibits. Oh, another powerful word. What? Pronounce this word before I pronounce it. Abscission. Abscission is a very Changi name, basically means the falling off. Why can't I just call falling off of the fruits and the young leaf, right? Okay, must put abscission. Yeah, it's Changi one, right? So the deal, you know, your medical human anatomy also really Changi names. So the plant group of scientists also they want to give Changi name, right? So abscission. All right, falling off of the fruits and the young leaves. So you see, it's very positive. The fruits say, "Oh, I masak already, I cook already, I ripe ready. I want to fall off." Okay, this oxygen say, "Don't hold longer." The young leaves say, "I want to fall off." Don't. You can do it. Okay, don't give up. Hold that. So you see, auxin, very encouraging hormone. Understand? Next thing, inhibits the growth of lateral buds. Another powerful word here. Not that powerful. All right. Now, we know this is the apex. Now, where is the lateral buds? So plants, have you ever wondered why plants become so bushy sometimes, right? All right. So these are the leaves, right? Now, they have this thing called BUD, buds, at the side that will slowly grow into branches, basically making the plant more bushy. All right. Because this auxin is mainly for dominance of the apex. Grow upwards, don't grow bushy branches. So they say, don't grow the bushy part. Don't make the plant more bushy, just stop. This is called lateral buds. Again, inhibits means stop. Stop the growth of sideways. Grow tall, don't grow bushy. Understand? So far so good. So this is what the plants do. So if they want to increase stability, then auxin will give them more stability by adventitious roots, right? They want to grow taller. Hey, sunlight up there. Auxin is the best friend. Pull them higher, pull them longer, get more sunlight, grow better. Understand? Survive. Can you imagine that? Yeah. Now let's look at application. How do we apply this in daily life? Or how do humans see like, oh, okay, so you can do your auxin, you can do this, huh? So let me do this with your hormones. Okay. Notice that it's involved in growth, increasing the height of the plant, right? You see? So humans make artificial auxin, spray onto them, and encourage the growth of their crops. You know the difference between crops and plants, right? Plants is just plants there. Crops is for human use, one, right? Right? Make you grow faster so that I can chop you down and cook you into vegetables. All right? Now, next things. Students, have you seen seedless fruits before? Yes? Have you seen seedless fruits before? Yeah, no. Tell me fruits that are seedless that you know before. What fruits have you eaten that has no seeds? Grapes, right? Most of the time you see seedless grapes, right? Seedless oranges also got. Seedless watermelon also got. Am I lagging? Testing 1, 2, 3. Am I lagging? No, huh? Okay. So, it is producing seedless fruits. Now, you always think, right? Hey, how humans produce seedless fruits, guys? Just to let you know, it's human induced. All right. is actually a flower. The flower supposed to wait for the male pollen to go inside and then form a fruit, and then you have the seed inside. That's natural process. Humans see, oh, flower, take the auxin, spray on the flower say, okay, I will grow into a fruit. I don't need a guy. Or I don't need the male to fertilize me. I can turn into a fruit myself. You see that, not? But the difference is there is no seed inside, no baby. Again, no seed inside the fruit. So this process of making seedless fruits is called pronounce parthenocarpy. Important. Parthenocarpy. Okay, so basically, take the flower. Just open flower like that. Okay, a very common. This is very common question. All right, and just spray auxin. This is a spray bottle. Yeah. Teacher, why can't they just use seedless fruit process? Not nice lah. So they put parthenocarpy. Understand? So far so good? Now, next. Next application. If I have a plant and I chop off the stem, correct? They say, oh, teacher, I have a plant that is chop off the stem. Can I just chuchok into the ground and let the roots grow? Yes, you can. But it has a higher chance of death because there's lesser roots. It takes time for them to grow roots. Agree? So what you can do is, here comes the rooting powder, rooting agent. The chop off one, we know that auxin stimulates adventitious growth, correct? So what you do is, when you apply auxin to the stem, you will start to trigger root growth on the stem. And then you can chuchok into the ground and then they grow better. You see that not? Can? Yeah. So this is the application. We can stimulate the root growth on the cut stem. So this is one application. Understand? Next, as a weed killer. Now, this is not the weed that you know, other form of weed. This weed is basically, all right, when you have plants that you want, and then after that, you have all those like tiny little grass that, or your lalang, or your grass, or your rumput, all these are called the weed. So we kill them using auxin. But teacher, I thought auxin is promoting growth. Well, weed killer at high concentrations. Remember, at high concentration, the effect will go the other way around. Okay, next up, induce potato dormancy. Basically, you know what's dormancy? Okay, basically I put in bracket, slows down the budding. What's the budding of a potato? You remember last week class where I told you I have a cabinet where I keep my potato, and then the potato start to grow, shoot out in the cabinet, right? Now, this is called budding. So I prevent this potato from creating growth shooting out. If I knew earlier, I could have used auxin to spray on my potato so that it does not bud or slow down. Actually, it grow already. People say, you don't eat already. Don't, okay, best don't eat this potato, throw away or plant it. Okay, now, done? So if you look over here, these are all very positive, very positive growth, positive kind of hormone. So far, so good, Ken? Yeah? Next up. Let's go to the next hormone. Gibberellin. One way to remember gibberellin is this. You know what animal is this? First answer in your mind is a monkey, right? I know. Everything is a monkey. Everything that looks like that is a monkey, correct? You forgot that, there's apes, there's gibbons, everything is monkey. Okay, so fine. Okay, this version of monkey, they call it a gibbon. Now, what separates gibbon from the normal macaque and all, right? Gibbons usually have long arms for them to swing from tree to tree, and then the body is elongated one, right? Compared to the normal monkey that you see climbing on the wires and all, those are usually macaques. Those don't really swing that much. They just sit down and eat nuts and bananas and steal your handphones. All right. So these are the gibbons. So those are macaques. So these gibbons, long body. So remember, gibbon is to elongate, highlight or underline, elongate the stem. Stimulates elongation of the stem. Okay, so again, long body. Now, what do I mean by that? Look here. You know what plant is this? It looks like it's a family of cabbage, right? Cabbage, lettuce, salad leaves kind of plant, right? Yeah. Now, if you spray gibberellin, the cabbage lettuce plant will grow up to this height. You see? Wow, cabbage can grow so tall, right? So what happens is there's a stem inside. You stimulate the stem to grow. So it's like a gibbon, long stem, long body, long stem, right? It stimulates the stem to grow very, very, very long. So this gibberellin. Understand? Okay. So it stimulates also, guys, this is one of the function. Again, put a star over here. This is one of the function. Another function is it stimulates the leaf to grow, flower to grow, fruit to develop. So it's very positive, right? So if you see like, hey, my fruit's very smaller, ladies and gentlemen, use gibberellin. Spray, 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 the fruit will become bigger size. Yeah. So the second function is they make your leaf bigger, flower bigger, fruit more developed. Walao, why this enzyme does not work with humans? First of all, this is hormones, not enzymes. Second of all, yeah, some of you wish this one works on human, right? Just spray, spray, spray on me, I grow taller already. Correct, right? Yeah, unfortunately cannot. So please do not go back home and buy gibberellin and shower in gibberellin. It will not help your growth. Okay, see the genetics. It's okay. Embrace your height. Okay. Oh, Adam is in the car. Okay, now, next. Again, very positive, right? So this is also very positive. It's very encouraging kind of hormone, right? Okay, stimulates, says the tall person. Well, so sorry. Can't help it. All right, so, all right, so stimulates seed development and germination. You know what's germination? Yes, no? You know what's germination? Germination is here, this plant, this one. All right, when I spray gibberellin, then we'll start to grow roots, will start to grow shoots. Do you still remember the conditions where the seed will germinate? What are the three conditions that have to be met? Only the seed will germinate out. It needs water, correct? It needs air, oxygen, correct? It needs a suitable temperature. Sometimes when the weather is too cold, winter time, okay, the seed will not germinate. But if humans spray gibberellin onto the seed will be forced to germinate. That's so sad, right? All right, grow now even though it's winter, right? So it forces them to grow, forces them to come out of the shell. Now, I would say force that stimulates the exit. All right, the germination. So next, stimulates flowering as well in dwarf plants. Okay, can just know at least. Inhibits root development. So it's like making the plant tall, but making the plant unstable at the same time. So there's a giveaway over here in terms of roots. Okay, but other than that, start the first and second. And the third one. So there's a lot over here, right? Actually, you only focus on 3 hormones only. Later, I'll tell you which 3. The other 2 not so famous, but I will still teach you. Yeah, this one object, few marks only like this kind of question. I will still go into the details because students get very frustrated when they read and then they have to go and find out all the words and all the names. So I just speed up the process. Let's look over here. Oh, I did wrong for the Basam Melayu one. Okay, so let's look. This one, paddy plant before. When you spray gibberellin, your paddy plant will grow longer, elongated stem, grow faster. You can use together with auxin, you can use gibberellin depending on your objective. Yeah, again, the keyword elongation in your stem. So it turns anything short plants into tall. Okay. So stimulates the elongation in flower stem as well. Some people want the flower stem to be longer. You know what's a flower stem, right? Okay, this is the stem, this is the flower, this is the flower stem. All right. Now, next. Notice that produce larger grapes. Why? Because they stimulate fruit development as well, right? So they make the fruit bigger. So you want bigger, nicer fruit, juicier fruits. Okay, gibberellin can be your answer. So before, small, 107 millimeter, but after spraying gibberellin, it increases in size. All right, so produces larger grapes. They have, okay, you see over here, right? Do the grapes really look larger? Do you think the grapes look larger? No, right? It's like smaller like that, right? Actually, okay, this is their maximum size. Why so? Because of their space availability. They have such little space to grow any bigger. So if I elongate the stem, then the plant can accumulate more nutrients in the fruits. So the fruits has more space in the future to grow bigger. Can you see that? Yes, no? Yeah? So they have more space to expand to a bigger size. Now that I elongate the middle stem. Yeah? So produce larger grapes. Of course, when the light intensity, the temperature is low, force them to germinate. We don't say force that. Promote them, encourage them to germinate out. Can't see so much difference, yeah. But this is after, but not long after. So you wait longer, then you see the grapes getting bigger than what they can be originally. Understand? Okay. Next one. The last one before you go for a short break. This one is cytokinin. Just now encouraging, right? This is a long stem, right? Long. Just think of elongation in stem. Next one, this is also encouraging. The last encouraging one. This is cytokinin. The word cyto comes from the word cyte, which means cell. Kinin, kinetic, it means, kinin usually means division. Okay, kinesis, cytokinesis, cytoplasm divide, karyokinesis, nucleus divide. So kinin, okay. What is it? Kinesis means to divide. So cell division, very easy from this. So what do you think it does? Cell division, exactly what the name is. Promotes cell division. Now, they are not them being alone, cell division is useless, right? You see, guys, if I cell divide, right, to become more, I'm just increasing my bulk of it, but my cell will still be very small size, correct? So usually in a science lab where they want to clone the plants called tissue culture at the bottom here, what they do is they will work together with another hormone. Again, tell me which hormone would I put together if I want these same cells to also elongate at the same time. So I have to go back just now, right? Long ox. So auxin is the one that elongates. So that's why cytokinin always work together with auxin hormone. Understand? So if you see in a question objective, hormone X is always used with auxin, cytokinin ready. Yeah, for cell growth. Okay, for plant growth can. Okay, next thing, stimulates seed germination. This one stimulates seed germination. So you know seed germination again, right? Seed and then germinates out. The same thing. You don't have to draw just to show you. Okay. Next. Just now is auxin makes it grow taller. See what is this doing? Inhibits the development of apical dominance. They say if cytokinin has more, they say shut off auxin. Okay. Shut off auxin function in apical dominance. Don't grow taller. However, stimulates growth of lateral buds. What's lateral bud again? Look here. These are called lateral buds. You see, if I spray cytokinin, what happened to them? They turn into branches. So if the plant want to make themselves more bushy, they want to increase their bushiness, then they'll release a lot of cytokinin. It will increase, and you get to see the branch. Wow, the tree is so bushy, so nice. Cytokinins work. Understand that? Okay, now this is one way to memorize. Site sounds like site, so means site growth. Okay, another way to remember lateral growth. Okay, understand? You see, delays leaf senescence. Did I teach this word just now? Did I explain the word? Don't have. I only thought, what is it called? I only taught you guys abscission. Okay, adventitious. Okay, another new word here. Senescence means, you learned before in last year, means growing old. Comes from the word senile. Hey, you senile already. You old already. Okay, everything also you forget. Okay, senescence. So the human growth, right? After adulthood is senescence stage, growing old stage. Yeah, so they delay. So the leaf say, hey, I'm tired of life already lah. I want to become brown. Sounds like a lot of people. I want to become brown and just grow old. Okay, then cytokinin say, don't. Okay, tired of life. All right, so don't do that. Okay, don't continue to remain green. There you go. Leaf senescence, delay it. Okay, hold a little bit longer. Understand? So cytokinin, cell division. Purpose promotes cell division. Okay? And then side growth, lateral growth, bushy plant. Stage of getting beautiful, Adam say. Getting more wise, filled with life experience, hold longer, okay? Make more food for the plants. Okay, now, next up. So what can we, so humans see, you can use it for cell division, right? Okay, so what are we going to do? We use it in tissue culture. Tissue culture basically means using a cell, taking a part of a cell, and turning the cell into a whole new plant. If I take a piece of a leaf, all right, you plant the leaf in the soil, what do you think will happen? The leaf will dry up and die, right? But if you take the plant and you cut them into, you take the leaf, you cut them into pieces, all right? And then you put them in the soil, they will still turn brown and die. So, but if you take these pieces and you put in a medium of nutrients, this technique is called tissue culture. This leaf, one small piece, is able to start to grow roots and start to grow shoot. It's not possible naturally. Okay? This is a human-made method called tissue culture. I turn them and make them continue to divide, and make them grow roots and shoot. So this is called tissue culture. All right. Again, by promoting cell division, and put a star over here. Always remember this one. Okay, important, yeah. Always use with auxin for growth. Division is not enough. You need elongation as well. Understand? You see the bushiness before, after. That's the difference. Cytokinin. The growth of lateral buds, more bushy. Next, again, delay leaf senescence. You see over here? They say they tell the leaf, don't grow old, don't turn yellow. Okay, it was all yellow. All right, so what happens is the leaf over here, Now, have you ever gone to a florist shop or you go to all these shops with florists before, right? Yeah, I'm sure you all bought flowers before, right? You see the leaf, some shops they sell flowers, yes, but some shops nowadays they sell the leaf only because it's so beautiful and nice. So they cut the leaf and then they display on the shelf and it looks so beautiful. And it's like, wow, I can imagine this on my living room shelf. All right, then you buy back home. You put in the living room shelf. 2 days later, the green turn yellow, the yellow turn brown, and then all you have is a dried leaf over there. Some of you even leave it there and then don't even bother throwing away. Okay? Yeah. So, what is the trick? Why do some of the florist shop they have like, wow, green color? Guys, cytokinin. Because it delays the yellowing of leaves, keeps them longer. Your thing is your marketing strategy. Your thing is true, right? Okay, to put over here cytokinin. Understand not? To keep it green, delay the yellowing. There you go. You can't die yet. Your work isn't done. Correct. Okay. Cannot finish yet. Your homework haven't finished. Cannot go and play. Haven't finished homework. Yeah, cytokinin. All right. Now, so far so good. Can cell division and cell aging is this. All right. So we take a short break. Later, 4:57. 5 lah. Okay, 3 minutes. 5 o'clock. All right. Come back for the next two hormones. Okay, ready? Come back, everybody. Where is Jaslyn? Yashwini, any idea?
I think so. She's tired.
Okay, so honest. Okay. Understand. It's Friday, it's a long day. All right, Ken, let's go to number 4. What's number 4? Number 4, hormone. Now, these next two, again, just to refresh your mind, the first 3, all very encouraging, right? Become longer in your cells, become longer in your stem, become more cells, divide a lot, correct? Now, this one, abscisic acid. Abs. Okay, now what's the meaning of abstinence? Have you heard of it? When I say I abstain from cigarette, abstain from smoking, abstain from playing video games, means what? I stop myself from playing video games. That is called abstinence, right? So abstinence means no, stop, don't. Okay, so abstinence is like everything I want to grow to more, no. I want to have more, no. I want to photo, no. I want no, everything, no. Just remember this hormone is just no all the way. Okay, semua pun tak boleh. So let's have a look at this one. First, the plant say, I want to grow. No, inhibit. You see that not? Yeah, just no. Why? Just no. Okay, don't. Then next, the fruits. I want to stay longer. I want to grow. I want to have flower. Abscission, destroy. Abscission means what? Falling off. I want to fall off now. All right? Fall. You see, so sad, right? It's very negative over there. Abscission of fruits, leaves, and flower. Okay, I'm enjoying the tree over here. Fall. Now, why is that so? Guys, the plant is not going to hold the fruits for one whole life just because you like it there, right? You have to drop off one day because I need to spread the seed. If not, the plant will stay there for so long. So I need to have abscisic acid and then to stimulate the falling of the fruit so that you can go and reproduce. Understand? Leaves too dry. I don't want to spend so much energy to maintain the leaf. So die off. Abscise. Again, abscission means falling off. Okay, in case you don't know. Okay, then the seed say, I want to break out. No, what is the meaning of dormancy? Dormancy means, yeah. The word dormancy means remain ungerminated. I want to come. No, nothing. All right, remains ungerminated. This sounds like parents. I want to go out. No. I want to play handphone. No. I want no. Why? Because I'm your parent. All of you like, you know my family. We all been through that. Okay. All right. Now, next, induce stomata closing during drought. Now, guys, look here. Induce means stimulate. Induce means start, stimulate. All right, encourage. Okay, now let me ask you, stomata. During the daytime, the stomata open, right? Correct, stoma open because the gut cells bend outwards, right? Because there's sunlight, the gut cells say photosynthesis time. Photosynthesis, draw more water in, and then the whole cell, the two cells open up, and then the stoma opens up. Correct? Then sunlight. So much sunlight. The cells go, wow, happy photosynthesis. So they open. Abscisic acid say, no, don't open. Okay? Don't be tricked by the sunlight. It's actually drought right now. Yeah? So what they do is, they say close. Even though got the sunlight, just close. Let the palisade mesophyll to do it, you close. Understand not? See? So it's a good thing also to say no. Correct or not? To protect you. Okay. I mean the plant. Next. Inhibits bud growth, inhibits seed germination. Same thing lah. Okay. Don't let the seed germinate. Don't grow any bud. Just No, guys, no, nothing. Okay, you see, causes it to fall off. So this is the use of abscisic acid. Another way you can remember is this word Abba. Abba sounds like father, sounds like mother, Amma, Abba. All right. No. Everything easy to remember. Okay, so what's the good? So what is the good thing? I don't want my plant to germinate now during winter or the weather not so good. All right. So you inhibit germination. Can use it to inhibit. All right. Inhibit is again stop. Okay. I don't want my fruits to ripe so fast. Can you tell me a situation where I don't want my fruits to ripe so much? Is there such a thing? Got okay. Let me tell you. Imported fruits. I buy from Australia. I import from Australia. Correct. I pluck the fruits today. The fruits are going to go through process, packing. And then these fruits are going to be transported to Malaysia, for example. All right. Now, these fruits, when you transfer to Malaysia, it's going to take few days again, correct? Enter, wait, few days, sampai our kilang, our pelabuhan, then few days, then sent to the shop, another few days, right? And then by the time it reaches the shelf, the fruit rosak already, correct or not? So I want to keep the fruit. No, don't write. And then reach the shelf, they will start to write. And then you go to the shop. Wow, so fresh. Then you buy. Okay, they spray hormone already. Yeah, so to prevent from ripening. Understand? So there's a use why you want to stop it from ripening. Yeah, we want seeds to be prolong their dormancy. Again, dormancy means remain as a seed. Yeah, you don't do that. So far, so good. Can? So this is a don't hormone. Yes, no? Can I understand? Next. Okay. What hormone is this? Ethylene. Ethylene is actually another name for ethene. Have you learned chemistry what ethene is? Yeah, alkene with double bond, correct? Very simple only, you see. I'm not giving you like, 1,2-methyl 3-dipropyl butyrene, all those long names. No need, right? Yeah, so you're just giving simple ones like that, okay? Ethene only, double bond, CCHH. All right, so ethene, another name is ethylene. You know that. Quite fun, actually. You guys enjoy this? Do you guys like this one? Anyone here like that chemistry chapter where you have to name your carbon compounds? You probably will like this branch of chemistry you will learn next time called organic chemistry. Yeah, all this alkene, alkane, carboxylic acid, all this is quite interesting one. If you like organic chemistry, yeah, some people like this whole thing. I used to like it a lot lah. Okay, quite interesting. You know, because it's just a formula. You just apply the formula only. Everything can be solved. Right? Okay, that's what I thought. All right, now let's go over here. How is Etty relates to auntie? It sounds like auntie. Sounds like, okay, sounds like, even though it doesn't, but I still have to find a way to whatever to make you all understand. Okay, so Etty sounds like auntie. And what does auntie like to do? Like to masak, like to write, like to cook. In Malay, masak, buah masak means they ripe faster, correct or not? Yeah, so think of fruits, they ripe faster. Okay, think of auntie using fruits to cook. Okay, then my students say, wow, teacher, is she making a orange porridge? Okay, what food is this? Okay, lemon curry, the strawberry naan. Okay, I've tried strawberry naan before. It's quite nice. Okay, mango curry also quite nice. Okay, if you haven't tried before. Okay, this one orange porridge. I don't know. Okay, anyway, so what does it do? The fruit masak lebih cepat. So it stimulates fruit to ripe faster. So in a way, is it a negative or a positive thing? Depend how you see it. All right. So the fruit want to stay green, right? And then you say when ethylene is released out, ethylene will cause the fruit to turn yellow. Okay. So This one is fruit ripening. So remember, ethylene is a very famous hormone to be asked. Write down. Next. Stimulates senescence. What is senescence again? The phase of senescence is a phase of growing old, right? Yeah, right? So that means basically yellowing and browning, growing old. Okay? Olding. What do you call that? Olding, adulting, aging. Okay? Stimulates abscission of leaf. What is abscission again? Abscission is the falling off. Yeah, very good. Okay, fall off the leaf, fall off the fruits. This is like enough time on the tree really. Okay, don't just go ripen and fall. Can? So, what is the good thing? What is the good thing of making the fruits ripe faster? People use ethylene in shops. If I say, yeah, the fruits arrive, just now too much ABA, right? Abscisic acid. Don't ripe. Sampai my shop still haven't ripe yet. So how? You want to stimulate it to ripe faster? Okay, I put another hormone, I spray ethylene. Then they will ripe faster. Put on the shelf. Humans go and buy it. You see that not? A lot of you like, oh, my life's a lie. I thought everything is fresh from the farm. Yes. 1 week ago, 2 weeks ago. Does ethylene affect our hormones when we eat fruits? No. So far, I haven't found any correlation between plant and human hormones. Okay, don't worry, it won't make any of our fruits to fall off. All right. Now, let's see over here. Promotes quick ripening of fruits before marketing. Promotes flowering as well. Yeah, you need a flower, the plant to open up. Ethylene as well. Can? Any question here? No. Okay, I got a question. Teacher, why do you put a mango in the rice there? What is this? Why is there a picture of a mango in the rice? Why no one asked me? Okay. You understand the banana, but you don't understand that thing. Okay. Now, one of the way to make the mango ripe faster or the fruits to ripe faster, there's many ways. Listen carefully, listen carefully. Okay. One way is to put the fruits next to fruits that ripe very fast. Can you think of fruits that ripe very fast? Come, throw in some fruits in. Like a few days, you see the thing turn already. Okay, mango, some more. Bananas, correct? Bananas ripe very, very fast. So what you can do is, you can put a mango with a bowl of other fruits, banana lah, oranges lah, whatever, right? They will secrete ethylene as well. And what will happen is you will accumulate ethylene around. Remember, ethylene is released by the fruit itself. It's a gas, right? They'll release the ethylene gas and then it will react back on themselves and they will cause them to ripe faster, one way. Another way is, have you seen fruits on the trees and then people wrap with plastic bag? People wrap with newspaper, correct or not? Yeah. Now, one reason is I don't want the birds to eat. Yeah, definitely. Second one is I want to accumulate, keyword, accumulate the ethylene gas. So the ethylene gas reacts back on the fruit so that they ripe faster as well. Understand? Still doesn't explain why mango is on top of the rice. Okay. So this one is our grandmother days. Some people still do it. Okay. Now, okay, Adam. Okay. What they do is they put the mango in the rice tong. Okay, last time, plastic bag, they don't use it, very valuable. So they use rice tong. So they put the mango inside the rice, okay, because they want it to ripe faster. Have you ever, to get mango sticky rice, have you ever experienced that before? I have, because much older than you, then we have, my grandparents are more ancient strategy one, okay? So when grandmother asked, hey, can you go and cook rice? What happened? I opened the rice tong. Why is there mango in the rice tong? All right. It's just not mango, guys. I find treasures in it. I find fruits. I find all sorts of fruit. It's like an orchard in there. All right. Next to our rice. Then they say, oh yeah, so that the fruit ripe faster. Never knew back then when we were younger. Now you notice the purpose is covered because the ethylene, all right, will come out and then will accumulate around, because the rice will trap the mango, right? So the rice will trap the ethylene and keep the fruit ripe faster. What did you miss? What did you miss, Adam say? What did he miss? How to make mango sticky rice. You can watch back recording. It's just basically what you miss is basically why we put fruits in a rice container or whatsoever. All right, now exam they ask you suggest 2 ways, suggest 3 ways where you can make the fruit ripe faster. First is manual. All right, so many way, right? So first you can spray with ethylene. Correct, spray with ethylene. Second, wrap in paper bag. Teacher plastic bag can problem. Environment friendly a bit, so we use paper bag. What else? Put in rice container with rice. Basically anywhere you want to store it, as long as you collect the ethylene. Okay, now essay focus. Suggest a way and give you all the points for essay. So let's say if they give you this picture, then put fruit in rice container. Next, fruits that are ripening will release ethylene. Ethylene will accumulate, ethylene is trapped and accumulated. Okay. This this increases the rate of cellulose breakdown. Who knew mango rice got so much words to write from there? Giving full answer for essay. Adam, you're in a car, not headache, are you? Playing phone, watching in a car. This would tajuk essay. Some students say, teacher, what word should I once form 4 student? I study so much already, but I just don't know what to write in exam. I understand everything, but sometimes teacher want the keywords. How? Yeah, in my class, that's why I give you all the keywords, right? You know what words to write. Release ethylene, trap accumulated must have, rate of cellulose breakdown. Okay, so rate cell breakdown is cell wall breakdown faster, fruits ripen faster. Must put all this. Okay, so this one is really essay or structure also can actually. Okay, usually it's a 3 to 4 marks question. Okay, can? Done? Okay, this is good enough already. We're gonna go into our revision again. Hey, where's Jinghao? Where's Jinghao? Are you there? Lying bed. All right.
Computer line terrible. Not
Oh,
even
all right,
anymore.
all right. Is it better now with without the video?
I mean, my phone is fine now,
Oh,
but
okay.
the computer just can't.
Okay. Faham. Okay. Yeah, if the where is the line is bad, just opt to turn off. All right, so let's do a short recap what we learned today. We learned about phytohormones, that means plant hormones. All right. So we learned auxin positive, long ox, cell elongation. Next, gibbon, long body, gibberellin. All right, elongation of the stem, the main part of the body, the stem. Right. Next, cytokinin increases in cell division. Always, when you want to use tissue culture, cell division is just increasing the cell mass. You want them to elongate and learn how to differentiate. So you need to put auxin. What else do you have to put? There are other chemicals as well, but you just need to know auxin and cytokinin good enough for SPM level. Yeah. And then abstinence, abscisic acid is everything is no. You want to grow, cannot. Everything you want to grow, cannot do. Understand? ABA. So this is a so-called negative one. It's not really negative. It's actually a way of protection or conserving energy. And then lastly, the auntie who cooks. Masak means cook. Cook means ripen faster. Understand not? Can? So far so good? Can? All right. So, chapter 5, latihan. Okay. For latihan, I don't have it here yet. So for latihan, please finish up 5.1, 5.2. All right. You don't have to go into this. If you see this kind of plant bending part, you don't have to do this part 5.2. We haven't learned there yet. Right? Basically the remaining and the roots. You don't have to know that. We'll go into that next week. Can or not? Yeah, I want to break it because I want to take this time now to do a little bit of revision before your midterm. Yeah? Are you ready for revision? Or basically, are you ready to be asked? Okay. Last week was chapter 15, right? Okay, no worries. Not ready. Also must ready. Correct. Why not get ready? Today, we are going to go into chapter 13. Chapter 13 is called Homeostasis and the Human Urinary System. How important is it? Very. Okay, cannot run away from homeostasis chapter. Ready? I have 3 students. All run away. No, I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 students in it. Okay. Adam, Go, Darren, Jinghao, Sanusha, Brian. Dialogue, GG, no study bio. Okay. Ready? Homeostasis is the maintenance. This chapter, we're going to go through it quick, all right? All right, it's basically maintaining what? What are we maintaining? Maintenance. What are we maintaining? A constant internal environment in living organisms. This is the definition that you need to know. Do you know it? Do you know this definition? All right. Now, maintenance or regulation, some people use regulation. All right. And now, this chapter you learn how to maintain what are the internet environment that you learn in this chapter? Can you tell me what are the parameters that you learn that you need to maintain in the human body in this chapter? I give you one example. You learn how to maintain body temperature. You also learned this in form 1 long time ago. What else? Blood glucose, some more. What else? Blood osmotic pressure, very good. Blood osmotic pressure, some more. Anything else? Blood carbon dioxide concentration, yes. And lastly, blood pressure, your BP, correct? Fine. Now, today, okay, I will do the easier one. Blood osmotic pressure. Teacher, what is blood osmotic? I know a lot of you don't know what is blood osmotic pressure, right? Yeah, that's why I want to focus on this. Okay, the temperature too easy already. Okay, so blood osmotic pressure. Now, what is blood osmotic pressure? Again, I'm going to do a bit of introduction. Osmotic pressure relates to the concentration of solute. Yeah, solute. So if this area has more salt or sugar, we say this thing is very OP, high osmotic pressure. This one got less solute, less salt, we say it has low OP. Understand? Now, can you give me a situation in our body or in our blood where we have high osmotic pressure in our blood? What situation can make our blood become high OP? Let's start. Adam. Oh, okay. Tanusha gave answer already. Okay. All right. First, fine. Okay. We drink less water. We drink less water. We got more solute in our blood, right? Okay. Give me other ways we can increase the OP. Adam or Darren. Anyone? What are the ways we can make besides that? Sweat a lot. Okay. What is OP again? Osmotic pressure. Okay, that means the concentration of solute. Okay, so we sweat a lot, we lose a lot of water. I haven't give marks yet. Okay, now give me a situation where my blood is low osmotic pressure. That means more water than usual. Salty food can. Yeah, this is drink a lot of water or too much water. Exactly. Very good. Now, we are going to look at this situation over here. All this osmotic pressure, we are regulating in the kidneys. Right? Kidney, Kidney got blood entering kidneys, got blood exit the kidneys, correct? And then the filter, whatever filters out from the blood will come out from this tube, correct? Called your ureter. Agree? Now, inside our kidneys, there are millions of these structures, tiny little structures called what? Adam, go first. Adam, go first. Adam. No. The whole thing. What is this whole thing called? Guys, I'm not kidding you. This is very famously asked. Kidney tubule. Yes, specifically, they are called nephron. We have millions of them. Understand? So, first, this blood vessel here will carry blood into, so I'll use pink color, will carry blood into the nephron, but it's not touching, very close to each other. And then will carry the blood outwards, in and out. Okay? Darren, look over here. In this process here, all right, blood will filter out water, nutrients, waste product. And they will travel all the way down, right? At the end of the day, I will absorb the important ones, and the urea and all, I will let it go out from here. Understand? Now, my question is this. There are three main processes that takes place in this nephron. Can you name me one of them? Or if you know, Darren, what is the name of the process that takes place here? The filtering, do you know? Starts with a U. Reabsorption. Okay, if you name one for me, reabsorption is correct. It's one of them. All right. Can I give you 1 mark for that? All right. This is called, thank you, ultrafiltration. Yeah. And then the next one, this is called reabsorption. JH. Next. What is this part? What process takes place mostly here? The third process that takes place in the nephron starts with an S. The meaning is similar to producing something useful out.
Secretion.
Yes, secretion, except this is nothing useful. This is basically removing all the waste toxins out. It's useful for the cell. Okay, so secretion. Understand? Three processes here. Now, what is important is this. In ultrafiltration, listen carefully. Why does the fluid know how to come out from here? How is the fluid exiting this this is called glomerulus. This is called glomerulus. I'm going to draw the Bowman capsule. I'm going to enlarge it. Okay, this is called a Bowman capsule. All right, Tanusha, try.
So the diameter of afferent arteriole is bigger than the diameter of efferent arteriole. This causes high hydrostatic pressure. This pressure causes ultrafiltration to occur.
Okay, thank you. This arteriole is called Brian, why you look like that? Efferent arteriole. All right. This is called efferent arteriole. So what makes them, what makes the liquid come out is because of the diameter. So if I want to draw accurately, the diameter of the efferent has to be bigger. So it is bigger. Okay, by the time it reaches here, and this one is smaller, right? So because there's a difference in diameter, this will cause a high new pressure form inside. We call it hydrostatic pressure, no space, hydrostatic pressure. This hydrostatic pressure will push and force substances out into the Bowman capsule. Now, if they were to ask you this one, mention the diameter difference, you get 1 mark. Mention hydrostatic pressure, you get a 2nd mark. Okay? Now, the next one is this. You need to mention what is filtered out and what is not filtered out. 1 mark, 1 mark, sorry. Okay, Brian, can you give me 3 things that is filtered out into the Bowman's capsule? 3 only out of gazillions. Okay, go. What do you think will filter out there? Some of the answers are very easy.
I don't remember.
Okay, try. What do you think will come out? Very nice, guys. I'm removing this out and it will go out from the kidneys and out from the pee hole. So what has to go out from there?
Water.
Water, yes. Water definitely will come out, right? Eventually. So what else?
Um, I,
See how smooth mouth is moving already. You see? Ooh ah, ooh ah. All right. Urea.
urea.
Urea
Okay.
has to go out, correct? Yeah. One more. Urine. Urine is, if I would say if you were to taste it, but what? So wrong. Okay, how would urine? How do you think urine would? I wouldn't say taste. Yeah. What do they have? It's urine a bit salty, right? Correct, not? Okay, I didn't say not like I tasted it. All right, but urine, okay, has some ions in it as well. All right, so NaCl. Now it will have some sugar for some people. All right, so you will have amino acids. Send this recording up. All right, and this is glucose over here. They all flow out. Understand? Okay. Next one is Adam. Adam, tell me now, all right, what is not filtered out? What cannot come out into here from your blood? Remember, this is blood, all right? So what do you think is in the blood that cannot filter out? Give me two things. Two ni. I don't ask for much. What is in your blood that cannot come out? Starts with an R, starts with a P. Hello, Adam. Cannot. Dylan, potassium. No, wrong. Potassium is an ion. Ion definitely can come out. They're very small. Okay. Dylan, try. What are the two things that cannot come out from your blood? Think what is in your blood that cannot come out? One with R, one starts with P. Another one starts with a PP. That's three. Got ready. R is red blood cells. Cannot come out. If come out already, you know what happened? Your blood will have urine. Your blood will have urine. Your urine will have blood. Right? Next, you do not have platelets. If not, you hilang platelet, then how are you going to repair back if you have any injury? Right? And then one more is plasma proteins. Okay, they cannot filter out. Jing Hao, tell me why they cannot be filtered out into the Bowman's capsule. Bowman's capsule. Why cannot? WBC also cannot. Okay, usually cannot. Okay, so why cannot filter out?
The answer very simple because they're too big.
They are too large. Wrong. They are too big. You need to write in full. They are too large or too big to pass through. Okay, tell me, to pass through where?
Pass through the
This is called glomerulus. So to pass through the
membrane of the glomerulus into the Bowman's capsule. Yes.
pass through the glomerulus wall. Understand? Now, students, I'm going to teach you one more time. When I say a substance going here out, I am crossing the wall. Understand? So I am moving past through the capillary wall, through the glomerulus wall. Understand? if students say pass through the capillary, this is what it means. Passing through the capillary. Understand or not? So be very specific in terms of your answering. No, cannot. Passing through is this way. Passing through the wall is this way. Membrane wall. No, not really membrane. This wall has cells. So many membrane walls. So yes. Okay. So you need to pass through the glomerulus wall. The wall of glomerulus into the Bowman's capsule. I give you 1 mark for knowing the answer because it's so easy. All right. Now, next up. Hey, everyone stop already. Testing 1, testing 2, testing 3. Can you guys hear me? Testing 1, testing 2, testing 3. I think my line cutting off. Can you all hear me? Oh no. I think all the videos suddenly stopped for a while. Can you hear me now? Yes, no? Can. Okay, all of you are moving already. Okay, good. Now, my brain laggy. Don't worry. Now, all the substance flow here. There is a process that calls reabsorption here. Reabsorption means I will take this one back here, right? Now, tell me, this structure here has a name. Tanisha, what is this called?
Proximal convoluted tubules.
PCT, proximal convoluted tubule, right? In this proximal convoluted tubule, students, which one do you think will come out here? Brian. Okay, which one do you think will pass through? Take a wild guess. Nah, you only have this one only, right? So you only have the blue one. So which of these will pass through? Come, go, try. Wrong, never mind. At least give me the answers. Quick, 3 more minutes. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, out of 6, 5 of them will pass through. Tell me which 5. Oh, teacher 1 bar.
Do you mean pass through the PCT?
Pass through the PCT walls. Yes.
Okay. Glucose,
Correct.
amino acid,
Good.
ions,
Okay.
and H2O.
Very good. Good guess. Okay. Not urea. This one going back to the body. We pour urea just to take back urea. What's the point, right? So the purpose is not take back the urea. Okay. So the urea will continue to go down and concentrate at the bottom. Now, mana. Okay. Which of this, if you want, Mark, Adam, Darren, I don't know, maybe a line problem, but you both of you can answer. Okay. Both of you tell me which 2 of all of these 6 are absorbed 100%. Go back into the body. 100%. Very good. Glucose, some more. Adam type glucose. Thank you, Darren. Amino acids. Exactly. 100% glucose amino acid will go back there. Understand? How are they transported back? What method of transport? Active, osmosis, facilitated, or simple diffusion? JH.
Teacher, can you hear me clearly?
Sorry, what did you say?
Can you hear me clearly?
Yes, very.
I think.
Yeah, so how are they transported? How glucose amino acid transported across?
Active transport.
Active transport. Good. Active transport, right? Okay, so the water comes out by osmosis. So that line will go down this bungee jump. What is this bungee jump? And the next one here called, Tanusha, name this thing.
Loop of Henle and distal convoluted tubule.
Distal convoluted tubule. All right. Now, what I'm left in this tube, like what Brian explained just now. All right. So glucose amino acid went back 100% already, right? So I'm left with these 4. All right. Over here, out of these 4, only 3 will be absorbed. Can you tell me which 3 will be absorbed back? Ryan.
H2O
Yes.
and ions.
And ions.
Still got
No more already. Good. Newly. Okay. H2O and ions will be absorbed back. Understand? So urea will go back down. Let me ask you guys, do you think 100% of the water and salt goes back out? Yes or no? No, not 100%. That's why urine still has some water in it. Okay. Next, final one. Final one. 10 marks. Tell me, okay, anyone here can type. What's the point of building the first 3 marks, right? All right. So the final one, tell me who or which hormone is involved to tell the water to come back out into the body. You only got one chance to type in your hormone. Which hormone will come here and say, take back the water? Answer is ADH. 10 marks. All right. Antidiuresis hormone. What is ADH? Antidiuresis is reabsorb water back into the body. Understand? Yeah. Okay. It's also in the name itself. ADH, right? Antidiuresis. Anti means don't. Diuresis means urine. Don't produce urine. Basically, take back the water into the body. You see that? Yeah. Okay. This is good refresher for you guys. Okay. So at least now you know all these things, right? Oh, just trying to be Tanisha, just trying to be politically trying to be democratic. All of you very good. So, okay, good try. All right. Next week, please improve. I'll see you next week, same time, same day. Finish your homework and then we'll discuss from there. Okay? Okay. Thank you. You may unmute yourself and say a farewell. Hey, Tanisha, go first. Okay, bye.
Thank you, teacher. Bye, teacher.
Thank you, teacher.
Bye-bye.
teacher, bye teacher.
Just now you asked that question on the last one was what? The one that you asked? The last one, the 5 phases of growth, and then
Oh yeah, like human consists of 6 phases, but insects, I'm not sure. What is that?
consists of 6 phases. Insects. You're right.
Consist-
What? This is the differences, is it? Oh, if you say sigmoid growth curve, if you put intermittent growth, then insect you have to put staircase shape curve. Yeah, you can actually. I've seen it using. I've seen the schema. Okay, let me get back to you on that. This is from my notes, right?
Yeah.
I think
from your
I think it's staircase shape, but I have to
Okay,
come back to you on that because your textbook did not use the word staircase. I've seen some schema using staircase, so I have to check back to you whether can use or not. Consists of 6 phases. This one, how you group them into phase. This one you have to explain really. There is egg, instar, and adult. Consists of egg, instar 1, 2, 3, 4, 5, and then adult. Okay.
Alright. Do I need to talk about acidices? I don't know how to pronounce.
Actually, sorry. Egg, nymph, and adult, not instar. Egg, nymph, and adult. Go back to the incomplete metamorphosis, that one. You have egg, nymph, adult, right? So egg, nymph, and adult. That's the 3 phases. Okay. Do you have to? Yes, you can also say, okay, egg disease occurs in insect. Egg disease do not take place in humans. Can. Yeah, can. Egg disease can also.
And teacher, similarities is both goes to growth, right? Both undergoes growth.
Both are growth in living organisms accepted. Both cause both involve increase in body cells, can. What else would you say? Both, I wouldn't say body length, right?
Yeah. Like
Both,
body.
go back to the definition of growth. See, growth is irreversible. So both are irreversible process. Both are permanent process. Both increase involve. So one easier way to do similarity is go back to the definition, the umbrella of it all, and both are the main title there. You get that? Yeah? Okay. All right. See
Bye,
you.
teacher. I will send you more questions. Is it okay?
No worries, no worries. Okay.
Bye-bye.
Bye.